Hello. So we are doing calculus ABBC and limits chapter. So today we'll do limits to a fixed constant. So we'll start with a very basic problem, but then we'll move to more challenging and I'll try to do more harder problems than that come in the AP exams, so you are better prepared for the hard exam in a class or AP exams. So first, let's start with the basic problems. So first is that we do direct step substitution. We always in the direct plug in the target x value first, and if it produces a real number, then that is the limit. So this is the question given, and let's try to plug in x because x tends to 3. So, and we have to find the limit of this function at 3. So we see that as we plug in x is equal to 3, we get the value which is 2. So 2 is the limit here. So this question we solved it just by direct substitution. Let's try another method. So this is a question given to us and it is the limit x tends to 2 in this function. So first let's try direct substitution. So as we substitute 0, x is equal to 2, we are getting 0 in numerator and 0 in denominator. It means we are getting a indeterminate form. So let's try a method by factoring and try to simplify by factoring. So we find the factors for numerator and denominator, and we see that x minus 2 is in numerator and denominator. We can divide it out, and now we can try direct substituting. X is equal to 2. So x minus 2 basically we're creating the indeterminate form. Now let's try putting x is equal to 2 and c. So on direct substituting x is equal to 2, we get value 11 by 4. So our limit is 11 by 4. So we get the value of the limit here, limit extends to 2 of this function as 11 by 4. Okay. So here we use the technique of factoring, and after that we did direct substitution. Now let's try some more challenging problems. So this is a question given to us. We can see there are two rational functions here. So first let's try direct substituting. Let's try to substitute x is equal to 3. So now in order to simplify these radicals, here we multiply and divide by conjugates. So here it was square root of 7 minus x minus 2. So we multiplied it and divided it by square root 7 minus x plus 2. And in the denominator, it was 1 minus square root of 4 minus x. So we divided and multiplied by 1 plus square root of 4 minus x. So this we did so as to we can remove the radical sign, because we know a square minus b square is a plus b, a minus b. So this is like a and this is b and this is a. So this is a minus b form and this is a plus b. Similarly here, this is a minus b form and this is a plus b. So we'll do a square minus b square. So this is like a square minus b square and this is a square minus b square. Now we know that square root of m, and then if we square, we get it m. Okay, so in this case, we'll just get 7 minus x. So in simplifying, we know now that we get 3 minus x here in numerator and minus 3 plus x. So because x tends to 3, this factor x minus 3 was only making it indeterminate. So now we see that it can be cancelled out on simplification. As we factor out negative out, we see that this is same, so we can cancel it. We can cancel x minus 3. Now we'll just directly substitute x is equal to 3. So we directly substituted x is equal to 3. So on direct substitution, we get x is equal to negative half. So in this question, when we saw the radical sign, we tried to put x is equal to 3 because we got the indeterminate form. We multiplied it with the conjugates, and we know a plus b times a minus b is a square minus b square. And then we saw that we got x minus 3, which was in numerator and denominator. We could cancel it out. And actually, that was the factor which was making the function indeterminate. Now, since it is cancelled out, we tried direct substituting x is equal to 3, and we got the limit as negative half. Let's do another type of challenging problem. So now let's try a limit of a function with absolute values. Learn limit of a function, how to find the limit of a function with absolute values. So this is a question given to us, and we will directly substitute. First, let's try direct substitution. So if we directly substitute x is equal to 1, we'll get 0 in the numerator and 0 in the denominator. So we are getting it indeterminate form. So let's break the absolute value and study the behavior of absolute value before 1 and after 1. Okay. Just when the x is approaching 1 or just after 1, like left hand side of 1 and right hand side of 1, and we'll try to get the limits. So we will write the piecewise function for this absolute value function, and we'll see the limits when x is approaching 1 from left side and when x is approaching 1 from right side. So this is a piecewise function, and we see its value is x minus 1 when x is greater than equal to 1, and it's negative x minus 1 when x is less than 1. So let's study at both the places and find the limit when x is less than 1 and when x is greater than 1. So we see here that when x is approaching 1 from left side, we put x minus absolute value of x minus 1 as minus x plus 1. Let's simplify this. So when we put it minus x plus 1 here, we simplify 1 and minus 1 gets cancelled, and then we factorize x out of x minus 1, we can factor x out, and then we can cancel 1 minus x, and 1 minus x we found in numerator and denominator. So actually it was the factor 1 minus x which was making the function indeterminate. Now let's put x is direct substitution, and we put x is equal to 1 and we got limit 1. So when x is approaching 1 from left side, we got the value, we got the limit as negative. Now let's find the limit of the function when x is approaching from right side. So the right hand side of x is equal to 1, or when x is approaching 1 from right hand side, then we substitute absolute value of x minus 1 as x minus 1. And now let's simplify this. So now x tends to 1 plus, so we substituted x, absolute value of x as x minus 1 here, and we uh, and then we factorize the numerator. We see that we get x minus 1 in numerator and denominator, so we cancel it. And now let's do direct substitution and put x as equal to 1. So we get 1 plus 2, which is 3. So limit x tends to 1 plus is 3. So if we graph, we see that before 1 or left hand side, we have this graph, and where limit of x tends to 1 minus of fx is minus 1, and when it is 1 plus, limit of x tends to 1 plus, limit is 3. So we can see that limit at left hand side and right hand side are not same, so limit does not exist. We see this question and we'll try to solve it. We can factorize also, but it will be more complicated. So we'll learn a new technique where we substitute variable. So let x raised to power 1 by 8 is equal to t. So x raised to power 1 by 4 will be t square. So as we see, now we are substituting x as t, our limit also changes. So here, when x tends to 1, t also tends to 1, because t is like, if we put x is 1, t will be 1 in this case. So t tends to 1. So we have to be sure when we substitute a variable, we have to substitute limit also. And here it is same, but it may change, because if the x is like 2, and then t, if it is x is 2 and x is equal to t square, then it may change to 4. But here it is not a problem, because x is tends to 2, then t x raised to power 1 by 8 is t, and x tends to 1, so t will be also getting to 1. So we need not change, and the numerator becomes t square minus 1 and denominator becomes t minus 1. So it's pretty simple now. Let's factorize. So on factorization, we can see that there are factors t minus 1, t plus 1, and t minus 1 cancels. And that was the factor. So here, this gives t tends to 1. So if we substitute t is equal to 1, we are getting, so when we directly substitute t is equal to 1, we get 1 plus 1. and it's equal to 2. So this is the limit of this function. And I forgot to show you in before here that when first we do direct substitution whenever we get the question and we got 1 minus 1 in numerator and denominator, we got 0 by 0, which was indeterminate. And then we tried substituting. So our limit here is 2. So now we'll continue practicing more harder problems in the next class. And please keep practicing and please let me know if you need help. Thanks for joining.